So in this related rights problem, we read that a small plane leaves an airport at noon, traveling 120 kilometers an hour on a bearing of 345 degrees. At 1:30 p.m., a second plane leaves the same airport traveling 160 kilometers per hour on a bearing of 75 degrees. How fast is the distance between the planes changing at 3 p.m.? Okay, well, first of all, let's kind of draw what's going on here so we can see this. So this is what I know. Okay, well, we've got this airport here. Now, a bearing of 345, let's draw my little crosshairs here. A bearing of 345 means from north, okay, from north, going straight north, I'm going to rotate this thing all the way around 345 degrees, so it's somewhere out here. Now that's going to put this thing like this, okay? And I'll deal with this in a second here, but let's just call this side A. So I know how fast the plane is going. That's going to be dA by dt will be 120 kilometers an hour. Okay, well, okay, I'll put the units in. We'll just remember those for right now because I didn't give myself a lot of room. The second plane, an hour and a half later, now that's going to be important, okay? It's going to be important for figuring out some of the details here, but an hour and a half later goes off on a bearing of 75 degrees. Now 75 degrees is going to be, again, from north. I'm going to rotate 75 degrees. So I'm going to be pointing out this way here. And then it's going to start to travel. Here's B. And I know that dB by dt is going to equal 160 kilometers per hour. I should probably try to fit those in. Okay, kilometers per hour, kilometers per hour. Okay, so then we're going to have this line connecting them. It's going to be this is going to be C. What I want is dC by dt. I want to know how fast those planes, the distance between those planes is changing. Now, we also know a couple of things here. First of all, the second plane leaves an hour and a half later after the second one here. But our time here at the end is going to be 3 p.m. Now, I'm assuming that's got to factor in. I don't know why I wrote that so close, but I'm assuming this has got to factor into the evaluating of our problem here. So time is equal to 3 p.m. Now, at first glance here, you might think, oh, no, I don't want to have to use the sine law or the cosine law for this, but actually you don't need to. That first plane went on a bearing of 345 here. That left us 15 degrees here, and this plane went on a bearing of 75 degrees. Altogether, that's 90 degrees. This is a right angle triangle. And so to relate those three sides, I'm going to use the Pythagorean theorem. And I know that a squared plus b squared will equal c squared. So now I'll start doing my work here. So a squared plus b squared will equal c squared. In this particular case here, everything's changing. These are all variables. And so this is an opportunity to look at a question where we've got more than just two variables related to each other. So I'll start by just taking the derivative. Now I take it implicitly with respect to time. So we're going to bring down the 2's here. So this will be 2a and then dA by dt, 2b dB by dt equals 2c dC by dt. And I'm looking for this guy right here. It's almost all by itself all over there. But anyway, first of all, I can cancel out all those 2's. And then I'm going to divide by the c here. And I'll bring the dC by dt over to the left side because most of us like it like that. And then this becomes a dA by dt plus b dB by dt, and this will be all over c. Okay, now I gotta just fill this in. Okay, so now what is a? Now remember, the moment that we're interested in is at 3 o'clock. That first plane, okay, that first plane has been traveling. It left the airport at noon. So at 3 o'clock here, it's been going for 3 hours. So it's gone 120 kilometers an hour for 3 hours. That's going to be 360 kilometers away right now. That's A. dA by dt was 120 kilometers per hour plus, okay, B. Well, B left at 1:30. And by 3 o'clock, it will only have been traveling for an hour and a half here, but it was going 160 kilometers, and so for an hour and a half, okay, that's actually going to be 240 kilometers, okay? So a full hour means it's got a full 160, and then it's going to go an additional half of that, so another 80 kilometers here. And it's going 160 kilometers per hour. Now, all of those rates there whatnot are going to be positive because in each case here, the plane is increasing that distance from the airport. Now, C. Okay, I don't know what C is. But fortunately, I have the Pythagorean theorem here. So I do have some information here. I know that A is 360 at that moment, and I know that B is 240 at that moment. What I don't know is what C is. So anyway, 360 squared plus 240 squared. Whoo boy, and I get 187200 is equal to C squared. I am hoping beyond hope that that works out to be a nice number. And it doesn't. So I know that C is going to be the square root of 187200. There's C. Now I'm going to end up taking this to the final decimal place anyway, so I'm not overly worried about that. There are some things that I could do to simplify that. Let me just take a quick look at a couple of things here. See if I can simplify that okay. Okay, actually I can take out a 40 here. I can make this 40 root 117, and I'm pretty sure that's as pretty as that's going to get here. So I'm just going to double check that that actually is the number that I want, and it looks good. So yeah, 40 root 117. So I can put 40 square root of 117 down here. And so now I'm just going to evaluate all that. Everything is there that I need. I just got to put it together. So 360 times 120 plus 240, 40 times 160. So we get 81,600 over 40 root 117. And now I'm just going to simplify by dividing that by 40. So I get 2,040 over the square root of 117. Now remember, our units here are kilometers per hour, and so this is going to be no different here, kilometers per hour. But that doesn't really communicate much to us, so let's go through and figure out what that is. And this is going to be roughly 188.6 kilometers per hour if I round that to the nearest tenth. And that gives you a much better idea of how these things are moving apart.